and that's how I won the Nobel Prize in Mathematics. See you later, Barack Obama. Oh, Miss Wu, didn't see you there. Now, throughout our time in calculus, we've learned a lot of different ways to solve integrals. One of them is polynomial long division to simplify the integrand. Another one is partial fractions. But what happens when you have to do both of those to solve just one integral? Let's see a practice problem and take a look. Smooth. Here we go. Let's take, for example, the integral of x to the fourth minus 5x cubed plus 6x squared minus 18 quantity divided by x cubed minus 3x squared. Now, this seems pretty complex. So to break it down, we're going to do some polynomial long division. Let's write it up. All right. So first, we see the first power to the fourth. This one's to the third. If we multiply by x, then we can cancel them out. X times x cubed, x to the fourth, is 3x cubed. Solve it out. This becomes minus x cubed. Swing this one right down. Yada da. And plus 6x squared. So now we have to multiply by minus 2 to cancel it out again to get to 0. You get minus 2x cubed plus 6x squared. Minus, this becomes 0. 6x squared minus 6x squared, also 0. Swing down the 18. But this can't go into negative 18. So we have negative 18 left as a remainder. So the way we're going to write this, this value divided by this value is equal to x minus 2 minus 18 over this part. Okay, so now we can rewrite the integral as okay. So this part and this part, it's pretty easy to solve, but this one still seems a bit complicated. So we're going to use a strategy of partial fractions to break it down. Now the tricky part here is that there's x cubed and x squared. So we're going to have an a, b, and a c. So we're going to rewrite this like this.
Minus 18 over, we're going to factor x squared, and then multiply by x minus 3. So this is going to have to be equal to some a over x plus some b over x squared, and then some c over x minus 3.
So now we just have to solve for a, b, and c. Let's start by multiplying the entire value by this. So minus 18.
X is cancelled out here, so it becomes ax times x minus 3 plus x squared cancels out, b times x minus 3 plus, and then x minus 3 cancels out here, so c x squared.
Now from here, we just have to continue solving. And we're going to isolate the a, b, and c variables.
Minus 18, we're going to multiply out a x squared minus 3 a x plus b x minus 3 b plus c x squared.
We want to continue doing it so that we have a and b and c in parentheses of their own. So again, minus 18 is
equal to, let's see, so ax squared and cx squared in common. So x squared times a plus c. And then we have ax and bx over here. So we can have plus x times minus 3a plus b. And then finally over here, we have minus 3b. Okay, so
you see on this side, there's no x variables. So we know that a plus c has to be 0, and negative 3a plus b also has to be 0. And the negative 18 quantity is going to come from this final part, negative 3b. So we can set up a system of equations. A plus c equals 0, negative 3a plus b equals 0, and negative 3b is equal to negative 18. This is pretty simple to solve. We've been doing this for a while. So b is equal to 6, negative 3a plus b. If we know that b is equal to 6, then a must be, that's right, 2. And then finally, c must be negative 2. All right, so now we have values for c, a, and b, and we can split up this fraction into more simple ones so that we can easily solve this integral right here. So can't forget our dx's. Let's rewrite this in our most simplified form. X minus 2 minus, so our a value was 2, so plus 2 over x. B value was 6, plus 6 over x squared. And c value was negative 2, minus 2 over x minus 3. And so now we can just use antiderivative rules to solve this out. So antiderivative of x, just x squared over 2, reverse power rule. And then for negative 2, it has to be negative 2x, derivative of this is negative 2, so it matches, plus 2 natural log of x, plus this one's a little bit more tricky. So this we can rewrite as 6x to negative 2, so that we can use reverse power rule. So this is going to become 6 to the negative 1, and to cancel out the negative when we get it into the integral, we have to multiply by negative here as well. So minus 6 over x, and then here is minus, again, 2 natural log of x minus 3. Of course, can't forget, plus c. So we have it here, but we can simplify a little bit more the 2 natural log of x and 2 natural log of x minus 3. We can simplify that using log rules. So this becomes x squared over 2 minus 2x minus 6 over x. And then here is just plus 2 natural log of x over x minus 3, of course, plus c. And that right here, ladies and gentlemen, is our final answer. All right, class, any questions?